Alright, so let's get started checking out the amazing Lizard system from Vinicius Electric. It's a complete self-contained Eurorack format modular system that has a really deep MIDI to CV converter right here, which has 2 trigger outputs, 2 gate outputs, 3 CV outputs, 2 of which are affected by the analog glide control right here. It also has the MIDI clock output, a pitch bend output, which is independent from the CV outputs, a modulation wheel output, and a velocity output. So normally you would have one output for these and it would have to be configurable. This thing actually has all 3 of them. It's really easy to configure the MIDI channel too. You just press channel right here and press a note in your MIDI controller, and automatically it's detected what channel your controller is in. Now after that we have 2 ADSR envelope generators, and here we can check and see if MIDI is actually, there you go, you see that LED light up on the ADSR. That means we're getting MIDI signal, and that's 2 of them. They're simple, but they have a few features that are useful, like you can choose between fast or a slow envelope. There are buttons so you can trigger them directly locally, so you don't have to trigger it with the MIDI to CV converter. And there's 2 of them. Normally for a subtractive type patch you would use one of them for the filter and one of them for the VCA. Here's the Lizard, which gives the system its name. It's a really advanced and deep module with many modes of operation. It's kind of hard to categorize this module since it does so many things. You can use it as a VCO, and as a VCO it's extremely powerful. I'm going to do a whole video on this module pretty soon, so I'm not going to go in depth about every single thing that it does, but basically it has a switch here that goes from VCO to sequencer, and the central position is external clock. When you're in VCO mode, there are 1, 2, 3, 4, 5, and 6 different modes, which are very distinct from each other. Each mode has up to 4 variations. So for example, if I go on the mode 5, which is the 2 LEDs lined up right here, we can take a look and see what the sound is like. Output 1 here is the output that would reflect the actual oscillator output. Output 2 is actually dedicated to the wave inputs right here, because this thing is also a multiplexer. So you can plug in up to 8 sources of audio or modulation sources. As a sequencer or as a oscillator, it'll sweep through these inputs in many different ways that are configurable and send them out to output 2. But output 1 is the output that's actually a oscillator output. So let's plug this in so we can see it in the oscilloscope. Alright, so we're looking at that blue line right there, and as you can see on the oscilloscope, that is a saw wave. Alright, and we can listen to it too. Let's plug the splitter that I'm using to go into the oscilloscope. Now if I turn the volume over here, we'll start hearing that saw wave. And if I change the type right here, this is HD oscillator mode, so it's actually a digital oscillator with all the classic basic waves, but it's running at 2 megahertz sample rate, which is ridiculous. So you can count on this oscillator to behave pretty much like a analog oscillator. Since the sample rate is so high, there's virtually no difference between this oscillator and an analog oscillator, except for the fact that it's extremely in tune and stable, because it's, you know, running off of digital clock rather than depending on the power rails. By the way, the power on this thing is totally linear. There's an AC adapter that comes with the system. This is a true modular system. It's not semi-modular, nothing comes pre-patched. In fact, the way that it's organized right now, it can be changed by the user. You can reorganize your modules any way you want. You can swap out modules and use the skiff for other modules, or put some of these modules somewhere else. Anyway, you're not in any way married to the format. This is just how the whole system comes, and you can also buy individual modules if you are more interested in just the Lizard or just the multi-waves. You can buy them individually as well. Although I have to say, as a full complete system, this thing is a real monster. It's really, really cool. It has a particular philosophy, patching philosophy, that goes with it, which is really interesting and unique. It has elements of East Coast synthesis and has elements of West Coast synthesis, and it has elements that are just pretty much out of Vinicius's mind and are unique to this brand and to this system, Vinicius Electric. Alright, so the second wave that you get on the HD wave is a triangle. There you go. Nice triangular wave. And it's absolutely pristine and precise. Here's the sine wave, also very nice sine wave. You can get up to very high frequencies and very low frequencies. This is LFO level right here. Same with the square wave. All the other modes, the first mode, you can call it the wave designer mode. And basically each knob represents a voltage that gets swept, just like a sequencer, but in audio rate. This means you can sort of draw your waves and emphasize different harmonics. It's a really cool mode. Draw like a little Manhattan skyline here. Mode 2 is also really interesting. It's similar to mode 1 in that the different segments of the wave are being drawn, except they're not being drawn by you directly, they're being drawn by individual LFOs on each step. What you can affect here is actually the frequency of those LFOs. So you can have a sort of living, breathing, moving timbre with different speeds on each LFO, and some of them can go up to audio rate. So you can get some interesting FM sort of sounds going. So already this is a really interesting mode 2, and the types work as well. So you get the backwards, you get backwards and forwards, and you get the random as well, which is now like a noise that's changing over time according to the speeds of the LFOs, instead of just like a homogeneous sounding chunk of noise. And of course that also works in sequencer mode, which is extra interesting because your sequence will be changing constantly. You're basically sequencing 8 LFOs, not fixed voltages. Mode number 3 gives you the super waves. So type 1 is the saw. These 4 knobs on the bottom here, they become volume controls for 4 other oscillators that get added to the central oscillator. And these 4 knobs over here, they affect the phase of each of these additional oscillators relative to the central oscillator. So let's turn up the first one, and there you go. You have a second saw wave of the same pitch. The phase relationship to the central one is affected by this knob right here. Now you can do that up to 4 times. So that's your classic sort of super saw sound. Now you don't only have the super saw, you have the other 4 types here. The second type is, there you go, it's a triangle, right? And same thing, you can add 4 other triangles to it and change their phase relationship to the original one. I guess this is in the category of the braids, as in that it's a macro oscillator, meaning it has many different modes of operation that give you different kinds of, it's like many oscillators in one, but it doesn't have a screen and doesn't really have menu diving beyond just the mode and type switches that light up, so you can easily memorize your favorite settings and get to them very quickly. Now mode 5 we've already talked about. It's the HD mode, so it's just basically your classic waves in really high sample rates. I mean extremely high sample rates. We're talking 2 megahertz here, not 48 or 96 kilohertz. Now the other one, the last mode here, I really like. It's really useful because it lets you do chords. So you still have the central oscillator, but then you can open up diatonic intervals. like that. Each of the 4 steps, you have the volumes on the bottom and the actual note up to 15 half steps from the fundamental. So you can construct up to 5 note chords, right? With the fundamental being the central oscillator, and then you have 4 other possible chord tones here. You don't need to use all of them. You can turn any of them down if you don't want, and you can balance them individually too with the volume controls here. I really like this mode for like pads and stuff, you know. Send it to the filter, for example. Yeah, let's do that. Let's use the filter. This is a very cool filter. I'm going to talk about it too. It's a state variable OTA type filter, but it's special and unique in certain ways. For example, it has a 18 decibel per octave output as well as a 12 decibel per octave output. It has band pass filter and high pass filter outputs as well. It has 2 audio inputs, so you can mix right in here 2 different sources that you want to filter, and it has 2 CV inputs for the cutoff with their attenuators, as well as a resonance CV control right here. And it does self-oscillate, and you get a very nice sine wave out of any of these 4 inputs. And they're out of phase, so if you get it really slow, you can sort of use it as a quad LFO too. Let's listen to our Lizard chord going through the filter here. You can change the waves too on chord mode. So that was saw wave. You can go into triangle, you can do it into square. The multi-waves module is mostly a modulation source. It can be used as a VCO as well. It has a digital section right here and 2 analog companion LFOs here, which are really handy and useful. You can use them as clock sources. They're voltage controllable. They have a symmetry control as well, and we'll use one of them to modulate our filter right now. With some resonance. Now let's sweep this filter with the LFO. So here's the LFO has a CV input, but the width knob, so it's like the CV attenuator knob, acts as a fine tune. So you can go a little bit faster or a little bit slower if you need to by fiddling with the width knob here. Alright, and you can also change the symmetry. So this is a triangle LFO, but if I turn the symmetry all the way to the left, it becomes a saw LFO, so a ramp. So right now, for example, as you can hear, it's ramping up the CV on the filter, and then abruptly comes back down. If I turn the symmetry the other direction, it becomes a ramp the other way. And of course, it's a continuous control, so you can get any position in between. In the dead center, you get the triangle, right? So here we are. So that's pretty cool sounding filter right there. You can add more resonance and hear that whistling, emphasizing different harmonics and different partials, and also different chord notes from our pad here. It also sounds very nice in 12 decibel per octave mode. And bandpass mode. Seems to distort a bit, so maybe turn that one down a little bit. Band pass and high pass. So the multi-waves is mostly a modulation source. Like as you can see, me using it right now to modulate the filter with one of the analog LFOs right here. Right? You have a second analog LFO just like this one, which you can cascade to the first one, for example, to change the LFO speed. So we can make one LFO make the other LFO go faster and slower. So you have more complex kind of modulations. Now the digital half of the multi-waves is much more complex than these. It has the same things, so you can still have a triangle, and here you have a button that selects the wave type. So you can go into a triangle, a sine wave, a square wave, a cosine wave, a peaked wave. You have both directions of ramps, and you have a white noise. It's digital noise, but it's noise nonetheless. And you have a sample and hold. When we have the sample and hold knob all the way to the left, it is turned off. Let's listen to the output here. It's still in LFO mode, but we can get up to audio rate, like low notes. That's the cosine wave. It looks the same as the sine wave. What changes about it is when you turn the symmetry. And here's an important detail about the multi-waves. On this half, you have a symmetry control for each wave. So you're not stuck with the preset waves. You can kind of draw your own wave by changing the symmetry on any of the preset waves. So for example, this is the cosine wave. Look what happens when I change the symmetry on it. It becomes that sort of pointy wave right there, and on the other direction it points downward. And not only do you have a knob to change this, you have a CV control over the symmetry right here. So I can actually send one of my other LFOs, one of my companion LFOs here, to modulate that symmetry. And it acts as the opposite of a filter. You add harmonics by changing the wave shape rather than taking off harmonics by cutting frequencies and approximating it to sine wave, right? Now let's go back to that cosine wave, and here's the peak wave, and now we're in LFO mode, which means you can get up to audible frequencies, but it really shines down low where it's mostly modulation source. Now the eighth type here, wave type here, is the noise. Now the noise, as you can see, is a digital noise. It's a lot of little steps alternating, but by changing the symmetry here, you also change the noise density, and you can get it to look and sound much more like analog white noise. And this is of course still voltage controllable, which can make for some really cool effects, like going from the very digitally sounding sort of noise to the more dense, high frequency white noise, right? Now once you go past noise, you go around again, there you go, a little light lights up, which means that you're now in VCO mode, and this half of the multi-waves becomes a VCO. So that just means it changes the range so that it's mostly audio level, right? And you still get all the same waves. Now, of course, on the square wave, for example, by changing the symmetry, you change the pulse width, right? But you can do that with a triangle wave too. So the triangle wave goes from a descending ramp through triangle to a ascending ramp, right? And same with the sine wave here. You can get it to be kind of like a ramp, even though it's not really a ramp, it's more of a curve, but it's, you know, intents and purposes, it sounds a lot like a ramp. And here's the cosine wave. We've already looked at it, and it does this thing. It's very different from the sine wave when you move the symmetry, and it looks the same when you don't. And here's the peak wave, right? And this is all modulatable too. So in a way, this oscillator, you can think of it as having its own filter-like provision, meaning that you can add or subtract harmonics based on tilting the wave, which is really cool. And it sounds different than a filter too. It sounds very unusual and unique, and it's very cool. So now you skip over the noise. There's no noise in oscillator mode, so now I'm back to LFO mode. Now if I put it back on noise and turn on the sample and hold, now we should go to listen to an oscillator. Now, and here's another thing, the filter is a really nice sine wave oscillator. Like any of its output will give you a sine wave, differing in phase. So you can actually use them, the outputs, for different processes. You can send one of the outputs, for example, into the over folder and fold it, and the other one directly into the mixer, etc. The other one you can use to FM something else. So it's nice. You have all four of these outputs put out varying levels, the varying phases of sine waves. Right, but right now we're just going to use the 12 dB per octave, which is the louder one, and we're going to send the multi-waves output to modulate the pitch of this sine wave. Right now we have it in noise. Wave type is noise, and we have the sample and hold turned on. So basically we're going to get a stepped random voltage. So let's stick that in here. So cool. So we can make it more subtle, more R2D2 like, right? And of course, the sample and hold knob gives you different speeds, from super fast to where you get, this is the actual noise, and then you start getting from super fast sample and hold to a fairly slow one. And then something really cool happens when you hit the maximum of this knob, which is it stops and this LED lights up, and basically it's waiting for an external clock. So that means that this sample and hold can be synchronized to an external clock. So let's synchronize it to one of the companion LFOs here. They have square wave outputs as well as the triangle or tilted wave output. So we put that in here, and now we can go slower than the slowest, because we can go as slow as this LFO goes. And as you can see, there's no drift whatsoever, because this is a digital sample and hold, so it's just gonna hold that voltage steady no matter what. There's no droop, there's no capacitor there that can discharge or anything like that. It's just a steady voltage. So it's a really cool sample and hold. Of course, it doesn't work only with noise. I like noise because it's random. But if you use any of the other waveforms, you still get the sample and hold. Right now it's VCO. Let's go back to, there we go. So that's a ramp getting sampled and held. You can make the frequency slower and a little bit faster sample and hold, so you get that stepped ramp going there. Let's see the triangle. Let's go back to oscillator mode. We'll choose a triangle wave so it's not too harsh. We'll plug it in straight. The width knob, which is basically the attenuator for the CV control, put it all the way up, then you have 1 volt per octave tracking of this oscillator. So that means it's actually a totally functional, useful musical oscillator that you can use in this system. Here we go. I just plugged in my Arturia keystep. As you can see, it's perfectly in tune. So one thing about the system is it doesn't have something that you look at and immediately say that's the oscillator, that's the VCO. It doesn't have a dedicated VCO. It has 3 different modules that can be VCOs. So depending on what kind of patch you're doing, you can choose one to be the VCO or the other based on which functions you would sacrifice or not to make a patch. But basically the filter is a very nice sine wave oscillator. The left side of the multi-waves in VCO mode that you can use as a VCO with symmetry control, which lets you modulate the wave shape in real time. The Lizard as a VCO, I already showed you some of the things it can do. It's amazing. It has incredible possibilities. So yeah, you would probably, I guess, use this as a VCO most of the time, or maybe both, the Lizard and the multi-waves. We'll grab the sine wave from the filter here. And we'll send it the sine wave from the multi-waves as a modulation source. That's using 2 modules that are not supposed to be oscillators, being oscillators, right? The multi-waves left side and the filter. And the other cool module that we have on the system is the overfolder. The overfolder is just a really cool wave folder, but it folds and then it overfolds. It folds over the wave. So let's send it the sine wave from the filter. Take the sine wave over here, and now let's take the output of the overfolder into our output module here. So I have my settings sort of low here, so basically you're not seeing too much folding, any folding at all really. We're looking at pretty much at the unaltered or very mildly altered sine wave from the filter. In fact, if you turn either of these 2 controls all the way counterclockwise, you get no sound at all, which means you can use the overfolder as a sort of VCA as well. By modulating, by sending it an envelope, for example, you actually make a sound or not. So even though you do have 2 VCAs in the system, you have this dual VCA at the end here, the overfolder itself can also be a VCA, as well as the filter, because with the filter all the way counterclockwise you get no sound either. So there's different ways to get silence with the system other than using the VCA. But let's take a look at what happens to that sine wave when we start folding it. So I'm just going to use the fold function first. And that's what that looks like and sounds like. And now I'm going to use the over. You get some radical timbres and effects by using the overfolder. Now the symmetry control also does some pretty crazy things. Check it out. And all of these are modulatable externally. I can send a triangle LFO to the fold parameter, for example. You can make it slower. There you go. So you can animate the timbre by using LFOs or envelope generators or whatever else, sequencers. And And I'll get into the overfolder in its own video some more later too. But in this introduction to the system, I wanted you to see everything that it has. So, and here's the 4-channel mixer, which can be used both for DC, as in modulation sources, as well as audio. So you can mix, for example, the overfolder output, the filter output, tilted wave from the multi-waves, all separately, and send them to one of the VCAs or both VCAs or whatever. And you have these two very simple but very effective and quiet VCAs right here, which basically just have an audio input, output, and a CV input each one. There are no knobs or anything, but it works great. I think we've talked about everything that comes in the system. It comes with the skiff, it comes with a very nice linear power supply, it comes with a whole bunch of cables, enough for patching in this atmosphere, and it has pretty much everything you need to already get going with sound design and music creation in Eurorack. So I consider this to be a really good starter system, or an expansion if you already have something like a Mother 32 or a No Coast. This adds a lot to something like that. Or even if you already have a huge modular system, you could always use these modules in your system. None of them are ever going to be redundant, because they each have their own idiosyncrasies and characteristics. The MIDI, for example, has a whole bunch of extra outputs that you don't normally get. The envelope generators have very nice response that is not the same as other envelope generators. The Lizard is a monster with a whole slew of functions that you won't find elsewhere. The Multiwaves is an amazing modulation source, as well as a really cool oscillator in its own right. The filter is super cool, super complete. You have 4 outputs, sine wave oscillation, attenuators for every input, resonance, CV controlled. The overfolder does some really gnarly, crazy sounding changes in your timbre. The mixer is just nice function, nice utility to have in the system. In fact, if you're not in need of a mixer but you need an attenuator, you can just use one of the channels to attenuate a signal before sending it to its final destination. There are no multiples, but there are redundant inputs and outputs and mixers already spread out through the system. But you can always use a little Ninja Star as a multiple if you need to. So let me show you how to make a simple subtractive type patch with the system. And there will be subsequent videos where I will show different patch ideas that are really cool and very unique to the Lizard system. So let's take everything out that I've already patched in. Already I've connected a gate to the envelope generator. I can connect the other gate to my other envelope generator. So now when I play a key, you see both LEDs light up on both ADSRs, right? So now I'm gonna choose mode 5 on the Lizard, which gives me different high definition waves, and I'll leave it in the sawtooth wave there. The multi-waves will also be an oscillator, so it's in VCO mode already. I can just tilt the sine wave slightly and it'll become its own thing. I have interesting harmonic characteristics beyond just the sine wave. So now we'll plug both of those into the filter. We'll take both those outputs into the filter. We'll take the 12 volt per octave output and we'll send it to the input of one of my dual VCAs right there. The VCA will be controlled by the second ADSR, and the first ADSR will control the filter. I'll stick it into one of the CV inputs right there of the filter. Cool. Also, why not take one of the LFO outputs into another input of the filter? We'll turn that all the way down for now. Now when I play, I should hear sound. That's right. So there's no pitch control yet. I haven't connected the pitch outputs of the MIDI to CV converter into their respective inputs in the oscillators. So CV input of the Lizard and also the CV input of the multi-waves. Make sure you have that width knob all the way up for a 1 volt per octave operation. So here we go. Now let's tune them together. Let's turn off the resonance on the filter, or turn it down a little bit. And And the cool thing is, in oscillator mode, the multi-waves, the sample and hold rate knob, which is not used, becomes a fine tune. So you don't have to rely on. You don't have to rely on just one knob, one coarse knob to find your notes. There we go. Let's tilt that wave a little bit more so you get more harmonics out of it. So I have 2 octaves going here. So now on my filter envelope generator, I will turn down sustain and we'll add some decay so we get this sort of thing. That's like your traditional subtractive type voice. Let's make the envelope affected a little bit less so that it doesn't close all the way, and let's add that LFO. Let's make it a little faster, a little more subtle. Simple as that, you have a subtractive voice. Now you can take, for example, another output of the filter and send it to the folder. And now we can take the filter output, instead of sending it directly to the VCA, we can send the mix output to the VCA. And we can send the filter output to one channel of the mixer and the output of the overfolder to another channel, and we can come up with even more interesting sound. We can animate that, send a triangle wave to one of its parameters. Make it maybe faster. Let's make a little sequence. So cool. I think this is it for the introduction to the Lizard system. Stay tuned for more videos with more in-depth explanation of each of the more complex modules. Alright, see you soon.